because that is basically just using this rule. Now what you could use for justification is this. What is x squared? And when we say x squared, what do we mean by that? X times x, okay. Really, based on what we said earlier, 1 times x times x. What is x cubed?
Same. X times x times x.
So I want you to think about it. When we look at those x's, we're increasing them, right? What mathematical operation would indicate increasing?
Adding.
Hey, what are we doing with those exponents?
Adding.
Oh. That's good justification, right?
So that would be the justification instead of the other one.
So when multiplying numbers with a common base, I guess we really should say powers. The factors,
Change the word on
sorry, yeah,
It's fine.
I'm trying to make it more mathematically correct. The factors of the base are increasing. So add the powers, or add the exponents. That, now, and you can use that justification of that example, right, to show that idea, but when we're multiplying powers with a common base, the factors of the base are increasing, right? So the number of a's that we're multiplying by increase. That is an explanation of why these things work. Is that a question you have, Donovan, or you're just stretching it out? Gotcha. So what about dividing numbers with the same base?
Subtracting.
So this would be a
Minus m.
a minus m?
A m minus
No.
m. A to the power of m minus m.
Like that?
Oh,
C.
it's like n minus 1 in a way.
It could be minus 1, it depends. But I do want you to notice, when we multiplied, we added, right? And division is the inverse of multiplication, so what do? We subtract, which is the inverse. Notice we can also create a quick example to explain this a little bit. Let's say I have x to the 5th divided by x to the 2nd. That is going to be x to the 3rd, based on the rule, based on what we know. It would be good to have a reference as a part of the justification, but you don't have to. I'm just giving this as an example to help us understand the justification in a second. What do we mean by x to the 5th?
1 times
5 times.
Okay, is that right? And then what are we doing?
Dividing. Then you do a little subtraction.
Some of them will cancel out, right?
Cancel out.
What is x divided by x?
Cancel it out. 1.
When you say you cancel it out,
1.
it's a 1. What's x divided by x?
1's a 1, Mr. Young.
So what are we
Got 3
doing?
left.
Notice we said we're increasing the factors of the base. Here, what are we doing? Are we increasing the factors of the base?
No.
We're decreasing, and what mathematical operation goes with decreasing? Subtraction. So when dividing powers with a common base, the factors of the base are decreasing. So subtract the exponents. All right. So I want to ask you all this. Is that true?
Yes.
We talking about with dividing, right?
Mm-hmm.
Yes.
No, it ain't.
No.
No,
Because there's only two A's
No,
and there's
it's
5
not.
X's.
that and, hold on, y'all. Just
Wait.
hold the horses. Let me talk.
Let's see what you got, Mona.
Alright, okay, 5 divided by 2 is not 3. Because, okay, then when you put in 2 and 5 3 times, and last time I checked, they equal 6. So,
Okay.
yeah.
Are we supposed to divide 5 and 2?
I thought we was doing them when we divided.
Well, we are dividing here, but what does it say? When we're dividing, we what?
Subtract.
Subtract.
Oh, okay. That
I
was
mean,
So
5,
it
so
is
5
right.
minus 2
I
is
thought-
3,
I
isn't it?
thought, since, you know,
So
you
it is
divide
right.
the powers
That's
in
on
the
a
other
common
one, where
basis.
you
That's
add
on a
up or
common
subtract.
basis.
Yeah, that's
Whoa,
not-
whoa, whoa. McKay actually has a really good point. And I know what you're saying, Mona, but do you see what's happening? That we're supposed to subtract. You good with that?
Mhm.
Okay. McKay, what were you saying?
It's not a common base.
It's not a common base. Hey, Mona, did he listen respectfully when you were talking earlier? Did he listen respectfully when you were talking earlier?
Yeah.
Okay, so let him talk now. And he has a really good point. We said when dividing powers with a common base, do these have the same base?
No.
No. Notice x to the 5th again is 1 times x times x times x times x times x divided by 1 times a times a. Can I cancel out those x's?
No.
Can I cancel out those a's? It has to be with common bases. These rules do not work if the bases are different.
Don't erase that yet.
But I need you to bring the attitude down a little.
No, I was trying to hurry up and stop you, because you be quick to erase.
But it's all about the attitude, or the way you say it. Hey, Mr. Kinney, can you, hold on a second. Now, which part do you need me to not erase? Because I was just going to erase x to the 5th divided by a squared.
Okay, now you can erase all of it.
Okay, so raising a power to a power. A to the m raised to the n. What would we say there?
Multiply.
Okay, so we're going to multiply those powers.
Yes.
So m times n.
Yes.
Anyone know why?
Because it's outside of the parentheses.
What? Well, yes, but why does that tell me to multiply those exponents?
Because the exponent is being multiplied by another exponent. They might as well just multiply them together.
Hold on, say it one more time.
I don't know what I just said.
Same. Let's look here. X to the 3rd raised to the 4th.
X to the 7th.
I thought you said to multiply the powers.
3 times 4. Oh, wait, never mind.
Okay? Let's slow down and let's think about this fundamentally. What does the exponent of 4 tell me to do?
Four times x cubed times x cubed times x cubed. Yeah, 4 times.
1.
I was about to go back and put that.
Sorry.
You're good. That's true, right?
Yes.
Notice how we have 4 groups of x cubed. So I'm going to repeatedly what with those exponents?
Multiply.
Repeatedly what?
Add them.
What mathematical operation would allow me to repeatedly add really easily?
Multiplication.
So notice how what this means is I am repeatedly multiplying x cubed 4 times. I'm repeatedly adding a to the m n times. And how do we show repeated addition? Right? So repeatedly multiplying a to the m n times. So the repeated addition of m becomes multiplication.
I did not realize you were writing on just a fish.
Here.
Sorry, I don't schedule. Yes, sir.
this graphic organizer should be a strong resource to help you understand differences and similarities and understand concepts. Now, please hear me very quickly. You see all these proper definitions I have in this graphic organizer for the vocab?
I see.
You see them? You see all of these examples and notes and connections that I provided as well.
Yes.
We don't have time to go over them right now.
Mr. Kenny, can you
Ma'am.
try to look for that? Cause I think I turned it in.
You shouldn't have, but here's my point. I'm about to post all of this on Schoology. If you want this information, you have to copy it off the Schoology or print it out. So notice I've given you proper definitions for the first front and back page. I've given you examples, notes, and connections within the units as well. That is a good resource to help you study and learn the concepts you do not know. I was planning on getting it done in class today. Because we took too long on certain things, we didn't get there. It will be on Schoology tonight.
Roll Tide.
This is what we'll get to tomorrow. Ooh, that is impossible to see. I will never use that again.
3.6 ready.
Well, that's
That's the wrong ones anyways, it doesn't matter. Hold on. So the stuff from last night, the materials that you had last night, it is numbers 11. So from last night's, it's number 11, it is number 15, and the one I made up. You need to redo it. Let me look at it first, but you probably need to redo it. So that is your homework tonight. Sorry that I forgot to update those. Tomorrow we're going to work on 2.6 more interesting.
I caught your arm right.
Sorry, retake it then.
Yep, that's what I'm doing.
Okay, Anthony, let me see what you did. Trust me guys, if you tried doing the one I created last night, you should probably redo it based on what we learned. That is not correct.
And
I think that actually helped a lot, and honestly,
That was not correct either. Why
So
did
you'll
you
be
take
the next
notes
one
on
to
the
go tomorrow then.
Yeah, that'll be me.
Did you take any notes explaining how you
Yeah, I've got
got
that.
these values? Remember all that work I did?
I'm something new, because I've never had any
Hopefully I'll do an okay job.
Well, so far you're
You gotta fix that,
I
right?
mean, you came down here and talked to another member of the group, and that was pretty good. I didn't finish writing that last justification before